Is this about girls?
No.
Okay, there's some problems up here you can start working on. The solutions, some solutions are over here. Don't look at these, okay? I just didn't want to take the time to rewrite all these up on the board, just pretend they're not there. If I had curtains, I'd pull them behind. Okay, so ignore these for the time being. So, it would be really nice to have curtains. And on some of the boards in other rooms, you know, I could just hide them behind other boards. Yeah, that would be a nice thing. Pay no attention to the solutions on the board. They're just figments of your imagination. Anyone have any exciting news to share? I have some sad news. Michelle Chambers, our TA in the 4 o'clock class, has COVID. So, yeah. So we wished her, she was online helping, but so we wished her to get well. But, one of my TAs last semester got COVID too. So it's a cursed position. So, Sam, you're next. Good. Anyone have some news to share? Someone in the last class shared that they have a steady girlfriend, so he was really happy. So officially dating someone. So, hey. Okay, let's get started. Who'd like to offer a prayer for us? Yep, go ahead. Remind me your name? Haley? Thanks. Amen. Thank you very much, Haley. Okay. Want to talk about the forum really quick? What comments did you guys have about the forum? One thumbs up? Yes.
I just thought it was super interesting. Like I always thought the opposite of like what he was saying, but I don't know. It just was really interesting.
Yeah, it was very interesting. One of the best forums I've ever attended. So lots of information, really fast, very clear, lots of connections to our lives. So, other comments? Yeah. Changing your major is not a bad thing. So that is right. Yeah, one of the Freakonomics authors, he did a study. He told people if you're thinking about changing your career, come to my website. We'll flip a virtual coin, and if it's heads, take the change, and if it's tails, don't. And so he followed up with people who actually did this. And although there's some methodological issues, because there's no guarantee about whether they take it or not. On average, people who made the change were happier. And one way to think about that is, like, if you're already in a career, and you're not happy, and you're thinking about making a change, clearly you have lots of information about that. And so chances are there's another career that's better than the one you're stuck in. And what's the chance that your first career is going to be the one that is going to be one that you really enjoy? Me, I guess that's, some of us have that option, but not all the time. Anyway, yeah, changing your major is not a bad thing. Multiple majors is a good thing, like all that experience and learning across the board. I have a good friend. He teaches in the English department. He writes essays. His undergrad was physics, and the background in his physics background, it sets him apart, and he allows him to bring different perspectives than most English majors who just majored in English and then got a PhD in English. So, okay, a few connections. So from the forum, you could see why Elder Bednar in the last conference would emphasize learning how to learn. He said that was one of his main goals as a professor, is helping students to learn how to learn, because the static knowledge that you're learning is not going to be what really helps you, right? You have to continue to learn and broaden your knowledge base and your skills and your perspectives to continue to be valuable. We use this in councils in the church, right? The idea, hey, let's get a whole bunch of people together with different, not a whole bunch, but some people together with different perspectives, with different information, then we can talk it out and help to make the best informed, inspired decision. And some of what he talked about relates to this, when will I ever use this question that comes up in math classes a lot. So I wrote an essay to students on when will I ever use this. And part of your assignment for your written work, I can't remember if it's on 2.2b or 2.3, one of your assignments is to read the essay. The link is in the assignment on Learning Suite. If you Google when will I ever use this, the very first link that comes up is the essay that I wrote. So, and it's been translated into Portuguese and Italian. So if you want those too, it's the one thing I've written that people have read the most. So yeah, it is kind of fun. So it's been read more in Italian than any other language, interestingly. So anyway, you'll have that assignment, and you have the assignment to read it, and then on the written homework you'll just write a paragraph to responding to some ideas in there. Okay. Questions on 2.2b? Who can tell me what the rank of a matrix is? So she's the number of non-zero rows in row echelon form. That's correct. The number of non-zero rows in row echelon form, which is equivalent. There's other things we could use instead of non-zero rows. What else could we use? Levi? The number of pivot positions, or the number of pivot columns, or the number of pivot rows. So all of those things are equivalent. So those are the ones I have listed here. One way to think about rank is that it's the number of pieces of information we have. It's the number of unique equations or unique vectors we have. Sometimes equations and vectors are just combinations of the ones you already have. They don't give you any more information. So that rank captures that number of pieces of information. Yeah, you can also think of it as the number of non-free variables. We have free variables, we have non-free variables. The non-free variables are called leading variables. We end up using free variables a lot more than leading variables. So it's the number of those leading variables. Yeah, so the book gave an equation like these. The rank is the number of variables minus the number of free variables. Or you can think of it as the number of variables is the rank plus the number of free variables. So, okay. All right. So for those of you that came in a little late after this announcement, there's some work up here on the problems of the day, 1 and 2. Ignore these, okay? Pretend they're not there and see what you can do on solving these problems. And if you have questions, raise your hand. And also you can, if you get stuck, you can certainly refer to these up here. Okay? You can work with each other. I'll be back in just a second. One quick note. These solutions up here aren't unique, like the pathway isn't unique, but once you get to a reduced row echelon form, that is unique. So you should end up with the same thing. But if you get stuck and you look up here and the students that put these up on the board took a different path than you, that's okay. There's lots of different ways to get to that reduced row echelon form. So don't let that bother you. All right, it looks like most people were done with the first one. Any questions on this one? The question is, why did you make us do this, Brother Corey? Yes.
So reduced echelon form is only one, right? There's no others.
Yeah, so reduced row echelon form, there is only one. So yeah, so so no matter what path you go from here, as long as you do the steps correctly, you'll get to the same thing. And any matrix that's row equivalent to this. And the row operations, they don't change the solution. So all of these matrices are row equivalent matrices, and that will all have the same solution. Like that's why we do row operations. We keep the solutions the same, and then eventually get to something where you can read off the solutions or easily describe the infinite solutions. So, yes. Other questions? Yes. Yeah, so that comment was, in the reduced row echelon form, we can just read the solution off of the reduced row echelon form, correct? Yes. As long as especially if we don't have any free variables, or when we don't have any free variables. Here, x equals 1, y equals 1, z equals 1, w equals 1. So yeah, that's one reason this is nice, right? Is this gets us, yeah, we can just read it off. Okay, easy to understand, easy solutions. In the other case, we get some free variables, so it's not as easy, but yeah. Other questions or comments about this one?
I guess like one reason that took me a long time was because I didn't realize, like it should have been obvious, but I didn't realize you could like chain together additional steps.
Oh, yeah, the student that put this up, he saw it would be pretty easy, like he wants zeros here, and he got to this point and he's like, well, I can just add this row and get a 0 and subtract this row and get zeros. So he did 2 steps at the same time. And then he did 3 steps because he's got 1, 1, 1. Hey, if I subtract each of those rows from here, then you get that. So yes. Yeah, there's sometimes people will start skipping steps or doing more in their head and other things. I encourage you to like use some ink so that it's easier to see, it's easier to go back and see where you make mistakes, and it'll keep you from making some mistakes. No one goes into mathematics because they like row reducing matrices, and this is something that can be done by a computer. So if you're having trouble on one, then one thing for you to do, doesn't work on the exam, but while you're learning, go to Wolfram Alpha and type in the matrix and just say row reduce. So the way you do that is row reduce, and then you open and close the matrix with curly brackets, and you just write each row in curly brackets too. So 2 minus 2, 3 minus 1, 3, close curly brackets. So then the next row, 1 minus 1, 2, a minus 1. That's supposed to be a 1 there. Sorry, I forgot to. Was it 3, 1, 4? Negative 4? Thanks. 1. Then the last row, minus 2, 2, minus 2, 0, minus 4. And then you close with a curly bracket. So if you just say row reduce that, it'll just do it for you. Okay? So we're not doing this to turn you into computers, but in practice you'll have other things row reduce for you. So, and on the exam, we usually give you things that work out pretty nice. So, okay. So this is one strategy. Another strategy, someone asked last class, like, when I make a mistake, is there a way to know what mistake I made? No, but a lot of mistakes come from students. Students ignore this column. So you just start focusing here and you forget to do the combination over here. So that's one place to look for it. And make sure you write down the problem correctly. I didn't do that on that problem when I was working on it before class, and I'm like, something's wrong. So, yeah. Okay, any other questions or comments about row reduction in general or this problem? Okay. Do you guys need more time to work on 2? Thumbs up if you want more time to work on 2, or 3 or 4. Okay, so yeah, keep working on those. All right. Let's come back on this one. So sorry this is so small. I caught the student at this point, gave him a larger marker, and still didn't make it too big, but we appreciate the student putting it up. So this student did a couple of things that may seem a little weird. He swaps row 2 and 3, and then he swaps row 1 and 3, and you didn't really have to swap 2 and 3, but he did. Then he takes a -2 of this first row, adds it to this row, gets 0, 0, -1, 1, 1, and then uses this 1 to get this to 0, and it ends up putting this whole row into zeros. Okay, so up to this point, we see that we have pivot positions right here and right here. Those are our 2 pivot positions. So we know what the rank is. Rank is 2. We know there's solutions. We know it's consistent. The only way for it to be inconsistent, which means there's no solution, is if you have all zeros in the coefficient side and non-zero over here. Okay, so that's the only way you can get an inconsistent solution. So we have solutions. We're not done though, because for this to be in reduced row echelon form, then all of the other entries in the pivot columns have to be 0. So use this one to get this one to be 0 by multiplying by a -2 and then adding. And so you end up -2 plus 2 is 0. -2 times a -1 is 2. 2 minus 1 is 1. And then you get 2 plus 1 is 3. So we get to this point, and that is reduced row echelon form. Okay, it's as good as we can do. Notice you've got these zeros here, or the leading entries make our stair-step thing. Questions on that? So questions on this process so far? Yes. Nope. It'll just come through. So it might not be at the bottom when you first do it, but if you do it and it's somewhere in the middle, just drop it. You just drop it to the bottom and the other one's up. So yeah, good question. So that question for those who are online was, are you ever going to have to choose to make a row 0 or not? No, you just do the row reduction process. If there's and the rows of 0 will emerge if they're there. So, okay, other questions? Levi, how do you put this in vector form? Great, that's the next thing we're going to do. So, nice question. So, I'm going to rewrite these as, first I'm going to rewrite this as a system. So, I'm going to write this as x. We'll call them x, y, z, and w. So, x minus y plus w equals 3. And then this I'll get z minus w equals a -1. Which variables are my free variables? So where are my pivot positions? Yeah, my pivot columns are in the x and z column. So those are leading variables. So my free variables are y and w. They're the variables that represent the columns where there are no pivot positions. So the free variables are y and w. Okay. So when I do this in vector form, I have a line for x, I have a line for z. So I have those leading an equation for each of those. Since they're free variables, these other ones, y equals whatever y we're going to set y equal to. Z equals whatever we're going to set Z equal to. So they're free variables. We can choose to be what they equal. Yes, not Josh. Hold on. Colin. Oh, yes, not Z. Thanks. Oh. I'm used to that last one being the Z column. Easy to make the mistake. Okay, W, thanks. So now what I'm going to do is I'm going to solve for X and Z here in terms of Y and W. So I want the free variables will all be on that side. So X equals, it'll be 3 plus a Y minus a W. Z, I'm going to put Y up here so we can keep it in order. So Y equals Y. Z will equal a minus 1 plus W. And W equals itself. So notice how I tried to keep things organized here. I tried to keep my constants here, my Y's, and my W's. Because I'm going to use that to put it into vector form. So now any X, Y, Z, or W, any point or vector will be this point 3, 0, a minus 1, 0. So places where I didn't have constants, they're just 0. And then plus, I'm going to pull out my Y. And I get 1, 1, 0, 0. Okay, did you see that those are equivalent? Pulling out the Y, I would just get 1, 1. I don't have any Y's here, so I can just put zeros here. Okay. And then for W's, if I pull those out, I get a minus 1, 0, 1, 1. So now it's in vector form, although let's drop the Y's and W's and call them S and T. So they don't have to, so then we have the option of changing these if we want to, these direction vectors. So yeah, so here's the point, a point that this goes through, and these are two independent direction vectors. So this is a plane, right? Because I have 2 dimensions I can work with. So this plane in 4 dimensions, it's a slice of 4 dimensions. It goes through this point, and it's any point in that plane are points that I can start from here and take combinations of these 2 vectors to get to. So right, those are going to be, I've got a point here, and I've got these vectors, and I can take combinations of these, and I can go out as far as I want here, and then I can go in parallel to this direction as far as I want. So that'll span a plane. Span is the idea that comes up in the next section. So, okay, questions about this? Yes, Seth.
So when you change the y, w to the direction vectors, you don't have to like call it 1y, 0y, 0y inside of the vector.
Like right here.
Yeah,
Yeah.
I mean like inside of the brackets that you put, like why don't you like distribute the y into the vector, I'm guessing.
So, like into this one right here.
Yeah.
We're already comfortable with the. It's easy to see the direction vector, and this just is the parameters we're dealing with. So this is just a nice form to work with it. We can easily see the vector, and we don't have the variables to get in the way. So, okay. Yeah, I mean, there's nothing. It's not mathematically incorrect to have them in there. So it gets closer to parametric form where you actually do that. But yeah, it's not mathematically incorrect. Yes. Okay, so my leading variables were x and z. Like I have pivot positions in x and z. They're not free variables. So when I translate this system into equations, are you good with that step? Going from these non-zero lines to this? Yeah. Okay, then I'm going to solve, I'm going to have an x in one and I'm going to have a z in the other. You'll always just have, any of your leading zeros, they will always just be in one of these equations. So I'm going to take the one that has x in it and I'm going to solve. So I moved the y and the w over. So this minus y, I added y to both sides and got a positive y. W I subtracted from both sides, became a negative w. And then same thing here. This is the equation that connects z. So I subtracted the z. I'm sorry, I solved for z by adding w to both sides. And so I get the -1 plus the w. You okay with that? Okay. And then these other ones are free variables. And free variables means we can decide what we want those to equal. And one way to represent that is we're just going to let y equal whatever it equals and w equal whatever w equals. And that allows us to complete the set. So y just equals y and w just equals w. They're in different orders because I want to have x, y, z, and w the same order that they are here. So put in x, y, z, and w, and then grouped all of the coefficients. I mean all the constants, all the y's and all the w's. Pulled out the y's, got this vector. Pulled out the w's, got that vector. Does that help? Thank you so much for asking that question. So that's a brave question, right? Hey, I still don't understand, but those are the questions we need you guys to ask. Yes?
So remember again, what that equation would give us, is this a plane or is this, it looks like there are 4 dimensions there, right?
This one? Yeah, so it is a plane. It spans 2 dimensions. So this is a point. This is, these are our 2 direction vectors. So we've got a point, we have 2 vectors in R4, so a 4-dimensional space. Yes, so you're thinking 4 because of these? Yeah, so we have these 2 direction vectors, but each of those requires 4 coordinates to put, because it's not in 3 space like this, it's not in 2 space like the plane, it's in 4 space. So it takes 4 coordinates to describe where they point to from the origin. Does that make sense? Yeah. But we only have these 2 dimensions to deal with. So we can only get we can only go this direction and this direction, and any combination of those. So we can go as far as we want in this direction, as far as we want in this direction, and any points. This describes all possible points we can get to in that way. So this x, y, z, and w are all possible points we can get at from starting here, going as far as we want in this direction, plus as far as we want in this direction. So, good question. Yeah, it's just a 2-dimensional plane in 4 space. It's so easy to picture. It's so hard. Yes, go ahead.
So I noticed that we have 2 pivot points and also 2 variables in the vector form. Are those correlated?
2 pivot points and then 2 variables in the vector form. You mean like over here?
Yeah.
Nice connection. What's correlated is the 2 free variables. So it's the 2 for every free variable you have here, you're going to end up with one of these parameters in a direction vector. So just so happens there's 2 of each, right? There's 2 free variables and there's 2 leading variables. So which ones, the connection here is with the free variables. So every free variable is another dimension in your solution set. So nice. Okay. Oh, we're just down to the last little bit. Way to ask those good questions. So the rank of each of these coefficient matrices. So the rank of this matrix is 4. Right, we have 4 pivot positions. The rank of this one was 2. So we have 2 pivot positions. What would happen if we replaced these constants with just zeros? If I did 0, 0, 0, 0. Then what would the solution here be? And if I replaced this with 0, 0, 0, what would the solution there be? So this is the easy one. What would the solution be? They'd all be zeros. This is called a homogeneous system or homogeneous equations if the constants are always 0. Homo means one or the same. And so, yeah, they're all the same. They're all 0. So that's where the homogeneous part comes in. Homogeneous systems, they're much nicer to row reduce because this gives you a whole column that you don't have to worry about because no matter what row operations you use, you cannot change these values. So that's really nice. And there's always a solution. There's always a solution. If x, y, if all of your variables are 0, then it equals 0, 0, 0, 0. So that's something else that's nice about it. It's never inconsistent. Over here, what do we have? You don't have to solve everything. The row reduction is going to go the same, except the part on this right-hand side will be zeros. So the only thing that's going to change at the end is these will be zeros. So the point that you start with that plane is the origin. So you have a plane that goes through the origin. We're going to use homogeneous equations a lot to help us make sense of matrices and some other ideas around matrices. Okay, have a great day.